Hi, everybody. Welcome to the Fireside Chat. So today, over the last few days, we've been listening to experts talk about machine learning, AI, and applications to different industries, and I hope you've enjoyed the sessions for the last few days. Now, we're going to kind of deep dive into autonomous vehicles, the hype and the impact of the industry. And so I'm going to would you like to introduce yourself again?
Yeah, definitely.
Awesome.
So my name is Riccardo Biasini, and I'm with comma.ai. I joined Comma in 2016, and I'm Chief Systems Architect. And prior to Comma, I worked at Tesla on the autopilot system and on the development of electric powertrains. And before that, I worked on research in electric vehicles at The Ohio State University.
So autonomous vehicles and automated vehicles. Let's start out with definitions, just level set. And I'm sure some of y'all were at the session this morning, but for the newcomers,
Yeah, I think a good way, as I mentioned before in the presentation, for the people that weren't here for the presentation, it's important to distinguish between levels of automation. The SAE defines 5 different levels, level 1, 2, 3, 4, and 5. And level 1 is pretty much like the car assists the driver, so the driver drives all the time, but the car makes intervention and makes driving safer and easier. In level 2, the car is fully in control of driving, and the driver actually assists the car. An example is Tesla's vehicle, GM Super Cruise, and what we develop at comma.ai. And then from level 3 and above, the driver is not responsible anymore. The car is responsible for the driving action. So the driver is not required to pay attention at all time. With level 3, the driver is only required to take control of the car after a few seconds of safe operation of the vehicle when the vehicle encounters a situation that cannot handle. And then for level 4 and 5 is completely driverless vehicle. And in level 4 is limited environment. In level 5 is full automation in unlimited environment. So basically making a robot that can drive as good as a human.
So autonomous vehicles has been pretty high in the news. So next week, when are they coming into the market?
Yeah, I mean, it's a good question. And the answer is certain levels of automation are already here. Level 1 is what you buy today. If you buy a new car, any new Toyota, like the most popular cars, have level 1 automation. Few cars on the market, and represent about 0.2% of the fleet today in US, are level 2. Mainly are Tesla autopilot. And then there is no released car in US that is like level 3 or above. And so when are those cars coming? Well, I would say first, we should try to increase the number of cars that are level 2. How do we make the existing cars like smarter? How do we make the fleet? How do we change the fleet incrementally? And I would say the natural way that it's going to change is cars are going to transition from level 1 to level 2. And then when level 3, 4, and 5 are going to be deployed, well, I would say, like I was said before in the presentation, I think one interesting level that we should be paying attention to is level 4. Level 3 does not make much sense because solving for level 3 is pretty much as hard as solving for level 4, guaranteeing a certain amount of time of safe operation. It's not a simple task, and solving for that is as hard, in my opinion, as solving for level 4. So what we are going to see at certain points is the deployment of fleets that work in limited environment and with driverless vehicles that can bring you to point A to point B. So hopefully we're going to see that in the relatively near future. But this level 4 does not compete with level 2. What level 4 aims to is the replacement of existing services such as Uber, such as public transportation. Is just meant to make those services cheaper by removing the driver from the loop.
So this has been a discussion we've been having before the conference. I work in the automotive aftermarket, and one of the things I do is I watch the car park and watch how it's changing and how it's going to be changing the next 15, 20 years to keep my company competitive. So when I thought, so ODBC connectors, OBD2 connectors, those are the little, you stick something under your dash, used a lot for some basic diagnostic functions, that's not smart enough. That's not connected in the right way to make my dumb car into a level 2 car.
No, yeah. So what we do at Comma, and it's taking existing cars, so proving that level 2 technology can be applied to existing cars. You can take any new cars that have level 1 capability, and we proved in the video that I showed you in the presentation that you can actually turn it into a level 2 car because cars that are new and comes out today have already the actuators and a way of communicating, of controlling the actuators, such as gas, brake, and steering, in a way that you can actually have the car driving itself if it is smart enough, if it has the right software and the right compute. So, yeah, I mean, like, if you, the way that you interact with the car is tapping into the CAN system of the car, and it can be done through BD2 ports, or it can be done from any other entry level present in the car.
So the technology needed to really hit the level 2 is model year 2016 and above, roughly?
Well, you need the actuators, you need the hardware that comes with the car, be ready to be upgraded, basically. So you need pretty much like, yeah, new cars from 2016 and above are a good target. So, but really, in 2019, almost any new car could be retrofitted with a level 2 in theory.
Does anybody want to guess what percentage of the car park is 2016 and above? Anybody? Who's brave? 20%. You're pretty close. It's 20%. So that also means that right now we have a lot of dumb cars on the road that won't be able to have the full benefit of, some aftermarket accessories. There's still some programming you can do through, there's lots of OBD2 port platforms. So for the novice car person who knows just enough Python to get in trouble, and GitHubs that can help you get there. But it doesn't take it quite to where it's the driver assist and have the functionality to...
Yeah, if you want the car to actually be driving itself, you need basically access to the actuators.
So the age of the vehicles is another thing that, the age of the car park has been something interesting that people in the aftermarket have been watching because people are holding on to cars way longer. In 1996, the average age of a car was 8.5 years. And you had it on the slide earlier. The current age, according to IHS, of a average car in America is 11.7 years. And it's been predicting to increase. Even when there have been movements like the Cash for Cars, that only took 670,000 old cars off the road. So yep. There's one challenge I think you're going to have is getting around those dumb cars.
Well, so definitely those cars like are going to be around for a long time, and it's highlighting one important fact that is if the average life of car is about like to 12 years, and it's actually like increasing over time. There is really this need of decoupling the hardware that comes with the car, so the car itself, like the chassis, the actuators, those are meant to last maybe 15 years or more from the brain of the car. That should be something that instead we should be treating as consumer electronics. It should be something that we should be able to replace, update. And I'm not talking just about over-the-air updates, so software updates, which none of the cars sold today except for Tesla is capable of doing. But I'm also talking about like being able to replace the computing hardware. In the last 15 years, if you think about cars 15 years ago and you think about cars today, I don't think the perception of the change of those cars as being like so big. Like, it still has 4 wheels, they cost pretty much about the same amount of money, and they serve pretty much the same purpose. What's changed is the cost of computing. In particular, like GPUs, they reduced the cost of computing in the last 15 years by 3 orders of magnitude. So it's 10,000 times cheaper buying GPUs, so having the same compute today that it was 15 years ago. And so if you think about it, well, think about cars that you buy today and think about them in 15 years from now, how outdated they will feel. An analogy that I make is like you are buying a house and you are not allowed to replace the washing machine. That's how cars are going to feel when you buy them now, and they are not structured decoupled in the proper way. So this is what we're trying to solve. At Comma, we try to make a retrofittable kit that can work with your existing car, and you treat it as a consumer electronic. You treat that device that you install on the windshield, connects with the CAN system of your car, with something that after maybe every 2 years, when a new system comes out, you can replace it. There is really no reason why you should replace the whole car to have better driver assistant features.
And that's also why we're seeing partnerships. We're seeing large automobile manufacturers partner with different technology company to start treating the technology in the car more like a consumer electronic. And that way you can have that upgradability. And as you mentioned before, Tesla is the only one who does over-the-air updates. So it does require some handling and care to get the data updated. But change in perspective like that is going to help. Treating it like the development cycle for electronics, I think, will help keep you happier when you have your 11.7-year-old car in a few years.
Yep.
Let's see. So issues with driverless. You talked this morning about data collection. Is there, data collection using your tool? So is that a limitation still for for the higher end cars and commercial? Are there pictures available? If we're talking, commercial vehicles comes up too. That was very, lots of magazine covers with fully electric 18-wheelers. How close are we to there?
Well, okay, so I think the distinction needs to be made between data collection that is made through devices and products that are currently sold. So if you work on level 2, like for example Tesla has the ability of collecting every day 4 million miles. Like they have enough car that every day they can collect 4 million miles. At Comma, we are about 30,000 miles per day that we can collect. And so if you have a product that you actually sell, it becomes a lot easier to collect the data. And you can actually be a little bit spoiled by the amount of data that you can collect. You can select, you can decide which data to upload. You don't need to upload all the data. Definitely Tesla is not uploading 4 million miles of data every day. So if you work on like level 3 and above, on something that has not been released yet to the public, then you cannot collect this data from people, from your device that are out in the field. But it's also important to distinguish between which type of data you can collect from people just driving a car and which type of data you actually need from the car that you prepared that are driving themselves. So think about like a fleet of self-driving car like level 4. Well, like if you are trying to learn to drive from data, you can gather this data from simply like people driving around. They don't need to be driving with your own car. You need to make sure that they have enough sensor and those sensors are representative of the car that you plan eventually to release for your final system. But you can distinguish between your fleet that you use for testing, to test your algorithm that are driving themselves, versus the fleet that you just use for data collection. So even if you are like working level 4, for example, in tracking, you don't need to have like self-driving tracking on the road in order to be able to collect data from tracking. You can like retrofit existing tracking with the right sensors and learn how to drive from people that are actually driving those trucks. So yeah, I think doing that distinction could help like getting into like the segment where it's a little harder to build like big networks.
And we've seen automation go into agriculture first, since you have, large areas, good opportunity for development, some software stuff that still needs to get worked out.
Yes.
Right, to repair.
Yeah, agriculture is a great example of automation already working very well. That's relatively easier than self-driving because the safety aspect of it is not like so relevant. But it's a great example, how automation works.
And then we've talked, for the last few days about having the right kind of sample set. How different are the videos and how applicable are the models from the different driving styles? So people in New York drive way different than people here. Places like Georgia where you have the long commutes like Houston. So is there prioritization? Is it one size fits all with these data?
Yeah, no, it's a good question. So for level 2, like for what we do, I mean, the more variety we get from data, the better. We try to build a system that somewhat works decently in pretty much like every driving condition. If you try to build something like a fleet of level 4 vehicles, I think you should focus on your first application. So if your first application is a system that is going to service people like in a suburban place where like speed is limited maybe like to 35 miles per hour, and like there is not like huge traffic, then maybe you should like focus on collecting data from those areas, because those represent your first like go-to-market application, and you shouldn't try to some sort of like mix in with data that is coming from environment that are outside the scope of the first release of your product. So it really depends. I would say like if you're focusing on level 4 now, don't try to get data from New York. Try to focus on where you're going to have your first application, and it's not going to be New York.
And we'd also talked about the applicability of car videos being used for like larger Class 8 vehicles. You know, camera, it's going to look different even for your modeling. So that's the good thing. There's a lot of data out there, and that microprocessors have gotten cheaper, although your cloud storage bill might go up a bit.
Yeah, that's the problem. Definitely, like those sensors have super rich output, like cameras. Like if you think about the stream of camera, it's like megapixels, and so think about how much data that is. Sure, you can compress your video, but it's still like we're talking about. I mean, in our case, our device collects pretty much between 5 and 10 gigabytes of data per hour. If you talk about like level 4, you're probably talking about like hundreds of gigabytes per hour collected by your system. And so, yes, I mean, like processing this data becomes like feasible now on in real time. But then at the same time, if you're storing this data, you have to think about how expensive is going to be your storage bill when you're like uploading all this data to your servers.
That also opens up, how can, if you're interested in working with, autonomous vehicles and car tech, the problem presents a good opportunity for developing new models for, we saw some models for the RCNN with picture refinement and different ways to classify images. So you're closer to it. So, how are different ways to get in, to be involved, or the other development opportunities that aren't necessarily in the car type,
Yeah, well, so self-driving cars are mainly like a software problem. It's not really a problem that has been some sort of like, I see it solved, and I see it like, I really frame it as a software problem. How do we make like a robot that can drive as a human, or can at least like assist human driving? So yeah, you don't need to be a car expert to be involved. You need, hopefully to have like passion for software, and there are like many aspects of it. You can work on machine learning. You can work on planning, controls, data management, infrastructure. There are really a lot of aspects about it that people like engineers can get involved with. If somebody is interested into getting more involved about it, we have like all our software. It's open source. Like comma.ai makes all the software open source. It's called OpenPilot. You can go on GitHub and you can read the application. You can read how our software stack works, and that software is the software that supports the hardware that we sell, which is called the comma Ion. So the hardware that we sell is a smart dashcam, and if you are interested into being like a developer and learning more about self-driving cars, you can actually put the two things together, and you can have like a level 2 retrofitted self-driving car, which is the one that I showed in the video. And
as everybody can imagine, the adjacent industries and even the service industries, as people's mobility patterns and habits change, they've already changed first with Lyft, and now you can get anything delivered to your house. So that opens up, as we're talking fleets have come up a few times. Either how could your business be changed by it? Is there some different model that we're seeing, be thinking of this when thinking of autonomous, which I'm sure everybody has been thinking of the impact of autonomous vehicles to your business. But fleets and adjacent services are interesting. The utilization rate.
Yeah. Yeah, definitely. Like one good thing about autonomous vehicle, like driverless vehicle, is that the expected like utilization rate is going to be much higher than any of the car existing. Especially think about like the trucking industry. the trucking industry, when we are going to see level 4 trucks on the road, well, trucking is going to become like radically different because you're not going to be anymore constrained by the maximum, I think it's 8 hours, like maximum continuous driving from drivers. You can have those trucks like driving pretty much like non-stop for as long as it takes to go from point A to point B. And so, yeah, certain industries, and I really look forward to trucking industries, are going to be radically changed by, for example, utilization rate. Other things that are going to change, I would expect, like the first application on level 4 being like, there is going to be a company that owns the fleet. Like I do really see, especially because at the beginning, there is going to be a lot of like iterations, like on the hardware, on the services, on the maintenance. There are a lot of like unknowns. And so I do see it making sense that there is going to be like a company that owns the fleet and uses the fleet as opposed to what we see today with Uber drivers, where it's very distributed. There are like single drivers that own their car and contribute to the fleet. Instead, I rather see those fleets being directly managed and centralized by the company that provides the service.
Yeah, and if upgrading is a bigger deal with the smarter cars, getting software updates and that have to happen, fleet management makes more sense in that, or can make a lot of sense in that context.
Yeah, exactly. Yeah, as I was mentioning, like there is this need of being like closely connected with your fleet, being able to upgrade your cars, and especially like at the beginning. So definitely, it's going to be like the first implementation. It's going to be like our own fleet.
Awesome. Does anybody know the utilization rate for a consumer car? Unless you're like an Uber driver, because that's, or in your car. The average, you end up not using your car. It's parked around 90% of the time. Whereas you can kind of flip that model with an autonomous vehicle. In delivery services, you can have like last mile issues. You actually might need to have a human doing some interaction. But again, looking for ways you can interact with this new industry, that is something. If there's not a driver in the car, how would your business work with them and serve them? So would that change any aspect of what you're doing now? Let's see. How about consumer adoption of AVs?
Yeah. Well, so okay, if we talk about level 2, it's really something that it's hard to convey. So just to have an idea, like how many of you have been in a level 2 self-driving car? Like raise your hand if you have been. Like I would say it's like 10%.
Yeah.
10% of you have been like in a level 2. Well, consider that there are 0.2% of cars are level 2 on the road today. So 10%, yeah, this audience definitely got a good exposure to them. And it's something that you need to experience, and you need to realize how better your driving can be and how safer it can be. Because you are basically relieved by the stress of constantly having to interact with your car, making sure that you're keeping the proper distance with the car ahead of you. Also, a car that drives itself has a much shorter reaction time because like you have a computer like watching the road and taking actions. And then at the same time, you have a monitoring system that constantly reminds you that you have to pay attention. And I mean, it's debated. There are voices that say this is actually going to be harder to manage from the driver because it's going to push people to get more distracted. I've been driving these systems, I've been developing this system, and everybody that I talked to that has been like on a level 2 systems has a pretty good opinion about how level 2 can actually like improve people's driving. So I think it's something like demand will grow as the offer will grow, as more and more cars will push towards level, will be equipped with level 2 systems. I think the acceptance rate is going to grow as a consequence. I would say for level 4, I think it's going to be literally like a question of costs. As I said before, level 4 already exists, and you can be driven from point A to point B without having to drive. It's just a matter of can I offer something that is like practical, can bring it from point A to point B with eventually the same amount or less time and the same cost or less. If that's true, then acceptance rate for like level 4 is going to be met. Is going to happen. Otherwise, they are not going to succeed. And it's not obvious that it's going to be the case. Definitely, I don't see it being the case for quite a bit.
So the National Highway Transportation Safety Administration has been a proponent of some of these driver assist because they save lives. Like the safer you can make cars, I think that helps me work through acceptance of like letting my, Siri yell at me about staying in my lane. Just because the balance of, inattention does, accidents happen when people are not paying attention. So I think that's going to help be at least a driver for it. And it's definitely messaging we've seen NHTSA do.
No, definitely, like the safety aspect is very important. I think there is a huge opportunity for level 2 to make cars safer. The starting point is not great. Fatal accidents are the number one cause of death among young people between age 16 and 24. And they represent about like 2% the cause of death worldwide. So there's definitely like a big opportunity there to make cars safer and smarter. Regarding level 4, there is a little bit like, I see a lot of like unfair comparison when we talk about safety related to level 4, because one of the things that is being said when people like talk about level 4 is, oh, well, it's going to be a lot safer. But again, you don't have to compare level 4 with like you driving the car. You have to compare level 4 with the services that level 4 compete with, which is public transportation, which is Uber driver, which if you take a Uber, I would say is probably like an order of magnitude safer than you driving your car, if anything, because he's offering your service and he's paying more attention than if you weren't in the car. So when you talk about safety for level 4, you need to contextualize it and compare apple to apple, which I don't see done like very often. While in level 2, well, you need to be better than people driving their car.
Do you want to take some questions?
Definitely.
Y'all had
Yes.
questions after us earlier.
Yes,
so.
great. A lot of questions. I think,
Go ahead.
yeah, that was before.
See any potential for complacency on if you're at level 2 for too long before technology hits level 4? Does the average driver out there that's tweeting, looking at Facebook on their computers, become complacent and get distracted? You see accident rates going higher than you anticipate. As currently level 2 drivers, they know they're in a Tesla, they know they're supposed to be enacting, so they're participating more. Yep. If the lag between level 2 and level 4 is years, do you see that people will trust it too much in the increase in accident rates?
No, I think it's actually going around, the other way around. I think like people that get into level 2 cars today are more confused about the technology, probably are not completely aware of the technology. One thing that I wish Tesla was doing that it doesn't, and actually we do, is driver monitoring. So how do we actively monitor that the driver is paying attention? That's a good way to like educate on the spot about what's the proper behavior to take when you're on a level 2 car. You have to pay attention. And yeah, I mean, if you have like a camera watching the driver, GM does that with Super Cruise. There is like a video camera, an infrared camera that looks at you and can tell you if you're distracted, and we do the same thing. And I think this is very important. So as we move forward, I think there will be, as the acceptance and the understanding of what level 2 system is, I think like drivers and users will be better educated because they'll understand what the technology is. So no, I don't. I expect that over time things are actually going to get better. People are going to be better educated than currently are.
And not to be punitive, but I think the other thing that naturally comes from that is as the drivers are monitors, that would be introduced as evidence in a court case at some point. So I think knowing that you have a camera on you also will affect, your interaction with it, not just, fall asleep on the 405, hopefully.
Well, I mean, yeah, I mean, it really depends. Like, I mean, currently we don't collect people's face unless they consent to, and they help us like training driver monitoring models. So somebody needs to actively consent to be able for us to record their data. Otherwise, we just provide the feature, but we don't record the data. But yes, definitely, like it could be a good opportunity.
Question up front here.
Yes, who is? Yep.
Okay, so I hope I can ask this question properly, but if I'm Ford, and how will I be adopting all of this? So what will it look like? So you're saying today Tesla is the only company that has this software update. Will all cars have that? What will Ford be doing over the next 10 years? What will their production look like to be able to start adopting this? What do you think?
Well,
I mean,
I can say it because I'm in that industry. So, and I've seen Toyota's been doing partnerships with Uber on both autonomous EVs and retrofitting like Siennas. So like regular internal combustion engine cars. And what I'm seeing evidence of is they're hedging their bets. It might move this way, it might go way more electric, you know, is the supply chain to support, you know, a more electric car part in place. But they have for years, although they might not be on the road, they are doing R&D and I'm not just saying for Ford, I'm saying in general for the car manufacturers, we're seeing them partner. They've started forming alliances. You can start seeing different clusters of ones that are working with others. So I don't think they have the full answer yet, but at least for level 4, for the different levels of development, they have been investing money in that.
So yeah, the way that I see it, like I don't know what they are waiting for, definitely, because I mean, if you think about that, like for a software recall, they have like, let's say you have a software glitch and it happened like in Toyotas, like several times, like on Prius, right? So you have a software recall, and to do a software recall, you have to recall millions of cars. How much of a cost is that? Like quantifies that, it's like hundreds of millions if you have to recall like millions of cars. That's the equivalent of money that you have to spend for a software update. And then also like the development cycle, your development cycle is much longer, right? So I mean, when you release, like the fact that you can do over-the-air update doesn't mean that what you release isn't safe, right? So you need to work out the safety part of your software before you release it, and that part doesn't change. But then I would say there is like an extra probably 70% that is just like user interface, things that are not safety critical, that if there is a glitch, it's not the end of the world, and you can work out those making updates over the air. So how much shorter will the development cycle be if you don't need like to test for so many hours the fact that if you click a button, the proper answer on UI happens, right, for example. So I really don't understand what they're waiting for, but the actual answer is, I mean, like those companies are very good at making cars, making reliable cars. They have a little bit to reinvent themselves if they want to be up to date with software, because it's a software problem. It's an infrastructure problem that you have to build, and it's something new. So, but they have to do it. If they want to be relevant, if they want to survive, they have to get into this. Otherwise, like, there is no way to compete with other companies that actually are making this a possibility. There is like there's a huge cost opportunity there. And yeah, they have to jump into it.
That's why I like partnerships, because there's a lot of value in people doing what they excel at, companies too. So if you're awesome at making cars, you know, partner with people who are awesome at the technology problem. All right, Carl?
Thank you. Yeah, just I want to return back to this, the concept of safety as you move through the different levels here. You talked extensively about that. What are some of the AI approaches that are being developed to address adversarial type of threats to smart vehicles? For example, you know, you can have like obstruction of signage, for example, and trick a vehicle thinking that, oh, that's not a stop sign, so I'm going to go right by it. So what are some of the solutions in the AI space that is being explored to make sure that as you move through those levels of autonomy, that these vehicles are getting smarter and not so susceptible to tricks and adversarial attacks?
Definitely. So, I mean, like the problem gets a lot easier the more miles you can collect, because you have the choice of deciding which data to favor. So, for example, like as I showed during the presentation, the large majority of data that you collect from cars, if you don't distinguish the one that is good and the one that is useful and the one that is not, it's like boring data. It's like you driving on the highway. There's not much to learn after a certain point. And so, yes, you need to favor those events that are somewhat events from which you can learn. So, like having a over-distribution of your data that are represented by specific events from which you can learn. And you can do that in many ways. Like one way that you can do it is like mark every intervention that the driver, like if you have your system that is like a level 2 system, every time that the user intervenes to correct the car, it's somewhat like a disengagement. It's somewhat like something that the car didn't do right. And so you can actually collect those events and favor those events to learn something specific that... Well, so reinforcement learning is a little bit, yes, reinforcement learning, well, that's somewhat different, like reinforcement learning in the sense that you deploy something and you use like the user as some sort of like your feedback, there is some sort of like ethical aspect to it that should be considered because you're using like the user as your like reinforcement loop. But in a certain sense, it's fair to do it as long as like what you release at any given time is safe. Now, more interesting, like you can do reinforcement learning like completely like offline, so you can train your model applying reinforcement learning. So you set up like a simulator, like we do at Comma, and you make the car learning from a reinforcement learning system. So you generate the data. So you generate situation where you put the car in a situation where it shouldn't be, and you learn from that. It's tricky. It's not a simple thing, but we have like good approaches at Comma that we are investigating, and we're actually like using right now on models that we are deploying. Yes.
Amber?
So I know you've been asked this probably 100 times before, and this question is not new at all, but I'm interested on your take on it. So the safety issue, if you have a car and there are pedestrians and the car has to decide if it's going to crash to save the pedestrians or the people in the car, or maybe a way to crash to save the people in the car in the front versus the back,
Yep.
How would a car make that decision?
Great. So you're right. I've been asked hundreds of times about this. And the answer is I don't think it's like very, very relevant problem at the moment. Like the technology is behind, and it's not at the point where like this kind of decision matters. And also, I don't think it's very relevant. Even if we were at that point, I don't think the answer is very relevant. At the point that you made like a car that is like driving safer than a human, like those sort of decisions are really down the point where they don't matter. I don't see such like, I don't see it even from an ethical point of view, I don't see it being like particularly relevant. Like let the engineer decide, like as long as the overall output, the overall system is like safer, it does not really matter. Like what would a human do? Like the only reason why we don't ask this question to human is because we think that it's happening fast enough that the human doesn't have to think about it. But so what would a human do? Let's say you have enough time to think about it. And in some cases, you might have enough time to think about this situation. What would a human do? And I would say another possible answer is, well, how to prevent this sort of situation beforehand. Like you want to be able to minimize as much as possible a situation where you have no good options. So that would be step one, and then step two is like, I mean, like what a human do. I don't think it's an ethical question that applies to robots. I think it's an ethical question that like could apply to human if you really want to ask the question, I think.
And I know during Startup Week, Drive AI did a presentation, and that question came up there, and for their models, they train to stop. So like even if it doesn't have to be an immediate safety thing, and this is, it was in limited deployment, but it was to take the car safely to a stop before they got to where it was collision close. But
Yes.
yeah, Donald?
We see driverless technology being applied to other forms of transportation, such as ships, boats, trains, planes, or even motorcycles.
Yes. Well, okay. In planes, it's already happened. It's not full automation, but like I would say like planes are the closest thing to what we intend as level two driver like the full self-driving cars. In agriculture, already happened. Like you have these like big tractors doing the field work without human assistance. Ships, I'm not an expert in ships, but I would say that, yeah, most of the ship work can be done without a human constantly like interacting with it, and there are probably like good warning systems to avoid colliding with icebergs. Other fields like train are already like pretty well automated. Like metros, there are like metros, like newer metros don't even have like a driver, like a machinist, like a person that stays in like physically looking into the metro itself and into the pods and like driving the metro around. So yeah, I mean it's already happened. I think it's going to happen, and it already happened sooner in other fields before it's going to happen in self-driving cars. So self-driving cars are probably going to be like the tail of these things, which is why when we talk about like level 5, this idea of having like a car that drives completely itself without the assistance of a human, as well as a human would, it's not something that is going to happen without us noticing it. It's going to be, I think, at the tail of many other fields that are going to be automated first. So we're going to know. When we're going to be close to level 5, we'll know it. If now we don't know it, it means that we're not close.
I think one good thing that comes out of it, though, is a lot of the technology used to detect things and solve problems in level 2 and up cars can be used for assisted technology on other modes of transportation. So they've already had kind of independent aids that can help, people navigate who are mobility challenged. So I think that is one just nice natural consequence of the development that's happening in your space. Okay, Anna?
So I'm going to ask you a question. I'm going to ask you a question which is a twist on the question about the pedestrian and the passenger. So obviously, you as a company and all companies will have tremendous incentive to make it an accident-free environment because one accident is going to drive your share price down. So that will necessarily limit what your car will allow the passenger to want to do. So if I want to speed in my own car and I'm driving, I have the full autonomy to do whatever I want and I'm taking my full risk. When the decision is delegated to the car manufacturer, they have the incentive to minimize accidents at the expense of individual passenger or owner autonomy. Can you express your opinion on that?
Yeah, I mean, I think people shouldn't speed, and I mean, it's like I don't see why cars are able to go up to 100 miles per hour. Like if the max limit is let's say 80 miles per hour, limit the speed at 80 miles per hour. Like the large majority of accidents are caused because people are driving in a way they're not supposed to drive. So limiting the way that the car is capable, what the car is capable of doing, is not a limit to freedom of owner of the car to drive the car. It's actually a smart thing to do. But I want to also comment on the first thing that you said, which is one accident for autonomous vehicle is going to be very bad, and there is a need to push for accident freeze. Well, I mean, perfect is the worst enemy of good, right? So let's focus where we are now, and let's try to make things better. Let's not overemphasize of accidents. Yes, there's going to be accidents, but we have a lot of accidents now. We need to make something that is better than now. If we emphasize too much, for example, we do with planes, when there is a plane accident, we emphasize it too much, then people are going to have this over-perception of what safety is. We need to do our best to avoid to get into this false perception that self-driving cars are not going to be safe because we have heard a lot about one accident. We have to weight it with actual data, actual numbers. We have to weight it with the 37,000 fatalities that happen each year in US. And so, I think we need to have a database approach when we talk about safety, and it's really important that we push for that. Yes.
So you're talking about an autonomous vehicle. Is there any development that a vehicle is part of a network and they will exchange information, like intent? What a car is going to do, it's going to turn right, and that other cars know.
So you're talking vehicle-to-vehicle communication?
Exactly. Or to traffic lights or whatever.
Yes, okay, so I think that's different things. I think one of them is good, one of them is not going to happen. So what is not going to happen, I think, is vehicle-to-vehicle communication. The problem with vehicle-to-vehicle communication are probably, I would say, two. One problem is it's going to be very hard to make every car manufacturer to agree on a protocol of communication. I just don't see this happening. So which type of data are going to exchange? Because you basically need to have many developers agreeing on a common standard. And also, I don't see it being necessary. You understand what the other car is doing by observing the other car. You don't need to know in advance what the other car is going to do, and also how do you trust? You are not the developer. If you're talking about vehicle-to-vehicle communication between your cars, probably you can do something, but you're not going to have a fleet that is large enough to be relevant and to be something that you can rely on. So if you have to rely on somebody else's development of attributes like intentions, path accelerations, those things that are not even simple to measure and to predict in the future, well, imagine trusting not something that you developed, but trusting something that somebody else developed. So I don't think, even if it was the case, I don't think this being useful. Like I don't see this being useful. One thing that instead I do see happening is vehicle to infrastructure communication, V2I or V2X. So V2X in general, like this idea that like the car needs some information from the infrastructure. So for example, like traffic lights, you want to optimize for traffic, you want to optimize for like going from A to B, you want to know the state of, for example, of traffic lights. And so, yeah, you can know that, but that's different because there is like a manufacturer that makes the standard, and then it's up to the car developers agreeing to a standard that they didn't have to agree to, they just have to comply with. So that's a little bit easier to push as a standard. And also I see it being useful. I see like, yeah, I mean, knowing in advance informations, that's definitely useful. And I mean, in a certain sense, it's already happening, like V2X. Like, if you want to know, like, I mean, like your GPS position, like in a certain sense, it's V2X, right? You are communicating with satellites. So it's just an evolution of what's already here. Yes.
So standards for communication already exist in the development world. Why do you think it would be different for autonomous vehicles? Like, well, why do you think developers wouldn't come together and create a set of standards that they can develop on?
Well, because, I mean, fundamentally, there is really no... So, that's like a reason, I'm saying, yes, you can build standards, protocol communication, but if there is no a real need for that, like a real advantage, that's another reason for that not to happen. So it's two obstacles, not only one. So agreeing on something is an obstacle. Not being useful is another obstacle. So if you put these two things together, that's why I see it's not going to happen for vehicles. I'm not saying it's impossible to agree on standards. I'm saying that if there is not like a big push for it, it's not going to happen. Yeah, I think if you like, the companies should invest on like understanding the environment, understanding what other cars are doing, predicting what other like players on the environment are doing based on what you observe from them, rather than having them telling you. Also, like, it's going to happen. It might work okay for cars, but what about cyclists? What about pedestrians? And those are like equivalently hard players on the environment that you have to deal with. And so, yeah. Even if it could help, it's not something that you can rely entirely because this information cannot even come from all the players in the environment.
Time for just a couple more questions. You got
Yes.
a mic?
Yep.
What kind of security measures you guys have been taking not to hack your software?
Yeah. So, I mean, like, okay, so when you develop systems for like level 2, it's different than when you develop like safety systems from level 3 and above. When you develop systems for like level 2, the driver is always responsible in the end. And so you need to make sure that every action that the car takes in autonomy is never going to be too abrupt to make the driver not capable of retaking control of the vehicle if the car does something wrong. So by doing this, you are limiting, for example, the amount of, like the operational domain of your actuators. Some example, like the braking system, you need to make sure that your braking system is never going to command too much braking deceleration, because if you are mistakenly braking when you shouldn't and you are driving on a highway at high speed, then you can cause an accident. So the way that you make those systems safe for level 2 is you limit your operational domain. What that translates into is you are making a system that by design is not going to be able to handle 100% of the miles that you drive. To give you like some numbers, like people that drive with the Tesla autopilot, from some statistics, so some people from the University of MIT collected a large data from a fleet that they monitored, and 32% of the miles driven are driven with autopilot on. For us, for people that drive with open pilot, it's 52%. We are working towards the 80%. Maybe 85. We know we are not, like, by design of a level 2 system is not going to get to 100%. There are certain environments where if you have the car operating in autonomy there, it's just not going to be safe, because in order to be able to drive in this environment, the car is taking actions that you might not be able to retake control quick enough. For example, taking like 90-degree turns in an environment where there are a lot of pedestrian around. Like, this is not a place where level 2 systems are going to work or operate. If you want to work in this environment, you need a level 4 or above.
We're running out of time, and
Yes.
you'll be here to answer questions in the
Yeah,
hallway.
I'm going to be around.
Awesome.
Yes.
Any parting thoughts before?
No, I would say, like, I recommend, like, if you want to get involved with a little bit more with Comma, go on comma.ai, our website, or go on our GitHub, explore our code, see what we do, and see what is like our approach of trying to make the existing fleet of cars smarter than what they are now.
Hope this was entertaining. Thank you, guys.
Okay. Thank you.